All right, let's unpack this fascinating essay about George Paget Thomson.
By author Yorgo Schneppet.
Right, you requested this deep dive, so let's explore his work.
Especially his groundbreaking discovery of electron diffraction.
Get ready for some aha moments.
As we delve into the quantum world.
You might be thinking.
Wait, wasn't his dad the E.J.J. Thomson who discovered the electron?
You're right.
Talk about pressure.
But George carved out his own path in physics.
And his work had huge implications
For how we understand matter today.
It's fascinating stuff.
So let's start with a quick overview of George Paget Thomson's life.
Born in 1892.
Died in 1975.
Immediately point out the family business element.
Son of the J.J. Thomson.
Early work was in classical physics.
But the quantum revolution was brewing.
Mention how he was influenced by Louis de Broglie's hypothesis.
That electrons might act like waves.
Here's where it gets really interesting.
Thomson actually proved de Broglie right.
Describe his electron diffraction experiments.
With thin metal foils.
The key takeaway?
He found patterns.
Similar to light diffraction.
Proving that electrons
These tiny particles
also behave like waves.
This is mind-blowing stuff.
And it earned him
a shared Nobel Prize in 1937.
Now let's compare Thomson's work
To the parallel discovery of electron diffraction.
by Davison and Germer in the U.S.,
They use a different setup.
but reached the same conclusion.
Highlight how this independent verification
Strengthen the foundation
of quantum mechanics.
and Thomson's role in popularizing quantum mechanics.
He wasn't just an experimenter.
He was a great explainer
His work helped bridge the gap
between the abstract theory.
and real-world observations.
So it's really amazing to think about the impact Thomson's work had,
Not just on physics, but on our everyday lives.
like electron microscopes, for example.
They wouldn't exist without his discoveries, right?
You're absolutely.
They've revolutionized fields like biology and material science.
So we could see those ripple effects.
Of Thomson's work all around us.
But let's shift gears for a moment.
The essay also touches on his involvement.
In the Manhattan Project during World War II,
That must have been a pretty intense experience for him.
it was a pivotal moment in his life
And I think it really highlights the complex relationship.
between science and society,
Here you have this physicist who had dedicated his life.
to exploring the fundamental nature of matter,
And suddenly he's thrust into this top-secret project.
with the potential to change the course of history,
And his expertise in uranium enrichment.
was crucial to the project's success
It makes you think about the ethical implications.
of scientific discoveries.
Absolutely.
Thomson was acutely aware of the potential for his work.
To be used for both good and bad purposes.
And I think that's why in his later years,
He became so involved in promoting science education.
and exploring the philosophical side of physics,
The essay mentions that he was particularly concerned,
about the responsible use of scientific knowledge.
especially in the context of nuclear weapons.
He saw firsthand the destructive power of the atom.
And it deeply affected him.
It's a reminder that scientists have a responsibility,
To consider the consequences of their work.
not just the excitement of discovery.
That's a powerful message.
But speaking of excitement,
I have to admit,
I'm still a bit fuzzy.
on how something can be both a particle and a wave.
It just seems so counterintuitive.
It is a mind-bending concept, that's for sure.
But think of it this way.
Imagine a stream of water.
Coming out of a hose.
You can think of the water as a continuous stream, right?
Okay, I'm following so far.
Well, in a way, that's kind of how electrons behave.
It can exhibit properties of both particles.
Like having a definite location.
And waves.
Like spreading out and interfering with each other.
So it's not that they're switching back and forth
It's that they have this dual nature.
all the time.
Exactly.
And it depends on how we observe them.
It's one of the strange and beautiful things about quantum mechanics.
Our observation can actually influence the way these particles behave.
Whoa, okay, that's getting a bit deep for me.
But I appreciate you trying to explain it.
It really highlights the fact that we're still grappling.
With some pretty profound questions about the nature of reality.
Absolutely, and that's what makes physics so fascinating.
There's always more to learn, more to discover, more to ponder.
And I think George Paget Thomson embodied
That spirit of curiosity and exploration throughout his life.
from his groundbreaking work on electron diffraction.
To his reflections on the ethics of science.
He left behind a legacy.
That continues to inspire us today.
You know, it's mind-blowing to think that all of this, like the electron microscopes and the deeper understanding of matter, it all stemmed from this one key discovery, that electrons can act like waves.
It really shows you the power of fundamental research. Sometimes, a seemingly abstract discovery can have the most profound impact on our lives. Who would have thought that exploring the wave nature of electrons would lead to technologies that have completely transformed our world?
It makes you wonder what other groundbreaking discoveries are just around the corner, what other mysteries of the quantum world are waiting to be unlocked. It's an exciting time to be alive. That's for sure. We're on the cusp of a new quantum revolution, with technologies like quantum computing and quantum cryptography poised to change the world in ways we can only begin to imagine.
And to think it all started with someone daring to ask, what if? What if the world wasn't as simple and straightforward as classical physics suggested? What if there was a deeper, more mysterious reality waiting to be explored?
That's the beauty of science. It's about constantly questioning, exploring, and pushing the boundaries of our understanding. And George Paget Thomson, with his brilliant experiments and his willingness to embrace new ideas, embodied that spirit of scientific inquiry.
He wasn't afraid to challenge the status quo, to go against the grain, even when it meant questioning his own father's legacy. And in doing so, he opened up a whole new world of possibilities, not just for science, but for all of humanity.
His story is a testament to the power of curiosity, the importance of perseverance, and the transformative potential of scientific discovery.
So thank you, Euro Schneepat, for giving us this insightful glimpse into the life and work of a truly remarkable scientist. And to our listeners, we hope this deep dive has sparked your own curiosity about the wonders of the quantum world. Because who knows, maybe one of you will be the next George Paget Thomson, making groundbreaking discoveries that will change the world.